Today you'll learn how to create this 3D game from complete scratch using Godot. Here you get to move the player with your keyboard, and by jumping you squash the enemies that increases your score. The course is intended to both beginners and more experienced Godot developers, so don't be afraid if you're just starting out, as I will explain everything I do in detail. You'll learn how to set up a scene, spawn monsters, how to program a jump and squash mechanics, and how to create a score counter. Everything said, let's start to learn Godot in 3D. In this first part, we're gonna to set up the game area, so let's get started by importing the start assets and setting up the game scene. Down below you will find a link in order to download the start asset for the project, so you're gonna scroll down, click here and wait a couple of seconds until your assets are downloaded. Once we have it, let's extract it. Now we will need to import the project.godot file into our Godot engine. If some kind of this window appear, we just click here, convert full project, okay, and that's it. And well, as you can see down here, we have all the art, fonts and assets that we are gonna be using in our game. To start creating our scene, let's just add a blank node. Now we will rename it to main. Now let's go to scene, save scene, and we're gonna save it right here. We'll start by adding a floor that'll prevent the characters from falling. To create static colliders like the floor, walls or ceilings, you can use static body 3D nodes. With the main node selected, add a static body 3D node, then a collision shape 3D. Rename the static body 3D to ground. To create a shape, select the collision shape 3D node, head to the inspector and click the empty field next to the shape property. Create a new box shape 3D. Click where it says box shape and set its size as here. As you can see here in the scene, we can see the changes. But as you can see, we can see literally nothing, as collision shapes don't have a visual style, so let's add it. Firstly, rename the static body 3D to ground, and then select it and add a mesh instance 3D node as its child. In the inspector, click on the field next to mesh and create a box mesh resource to create a visible box. As you can see, it is so small. Click the box icon to expand the resource and set its size. Collision and mesh sizes should be the same. Select the ground node and move it down 1 unit, so it should be -1. Let's add a directional light so our scene isn't all gray. Select the main node and add a child node directional light 3D. Now let's move this directional light a little bit up and let's click on this red arc right here and rotate it a little bit in order to actually light our floor. Here in shadow, let's enable it. In the next 2 lessons, we will design the player scene, register custom input actions and code player movement. By the end, you'll have a playable character that moves in 8 directions. Create a new scene by going to scene and then new scene. Create a character body 3D node as the root, and also you should rename it to player. For now, we're going to create a basic rig for our character's 3D model. This will allow us to rotate the model later via code while it plays an animation. So, add a node 3D node as a child of player and name it pivot. Then, in the file system doc, expand the art folder by double-clicking it and drag and drop player.glb onto pivot. This should instantiate the character, as you can see, so let's rename it to character. Select the player node again and add a child node collision shape 3D. In the inspector on the shape property, add a new sphere shape 3D. Then change its radius to 0.8. Hide the pivot and move the shape up so its bottom roughly aligns with the grid's plane. Again, go to scene, save scene and save it as it is. To move the character, we will listen to the player's input. like pressing the arrow keys. This system is the input map on Godot, so let's go to project and then project settings. Click here input map. Here we will create 4 movements and 1 jump. I will assign WASD for the movement and the spacebar for jumping. It's time to code. We are going to use the input actions we created in the last part to move the character. Right-click the player node and select Attach Script to add a new script to it, and in the pop-up select the template to empty before pressing the Create button. We are going to define a movement speed, a fall acceleration representing gravity, and a velocity we'll use to move the character. The target velocity is a 3D vector combining a speed with a direction. Here we define it as a property because we want to update and reuse its value across frames. We start by calculating the input direction vector using the global input object in physics process. Here we are going to make all calculations using the physics process virtual function. Like process, it allows you to update the node every frame, but it's designed specifically for physics-related code like moving a kinematic or rigid body. Also, I changed these 2 names in the input map. Back used to be down and up, and forward used to be up. We start by initializing a direction variable to vector30. Then we check if the player is pressing one or more of the move inputs and update the vectors X and Z components accordingly. In case the player presses say both W and Z simultaneously, the vector will have a length of about 1.4, but if they press a single key it will have a length of 1. We want the vector's length to be consistent and not move faster diagonally. To do so, we can call its normalized method. Here we only normalize the vector if the direction has a length greater than 0, which means the player is pressing a direction key. In this case we also get the pivot node and call its look_at method. This method takes a position in space to look at in global coordinates and the up direction. In this case we can use the vector3up constant. Then we update the velocity. We have to calculate the ground velocity and the fall speed separately. Be sure to go back 1 tab so the lines are inside the physics process function but outside the condition we just wrote above. The isOnFloor function returns true if the body collided with the floor in this frame. That's why we apply gravity to the player only while it is in the air. For the vertical velocity, we subtract the fall acceleration multiplied by the delta time every frame. This line of code will cause our character to fall in every frame as long as it is not on or colliding with the floor. We update our current velocity with our target one. On the last line we call move and slide, which allows you to move a character smoothly. If it hits a wall midway through a motion, the engine will try to smooth it out for you. Make sure all of your changes are completely saved, and let's instantiate our player in our main scene. So let's go to our main scene, select our main node, click this icon that is to instantiate child scene as you can see, and let's select here our player. Let's add the camera next. Create a marker 3D inside our main node, name it camera pivot, select it, and add as a child a camera 3D. Let's click here where it says preview. We can actually preview what the camera sees. As you can see, it doesn't look good. So let's put here under transform position 19 in the Z axis. Then select your camera pivot and put -45 in the X rotation. As you can see, we have a bunch of empty space all over here. So let's fix that. Select the camera again and in the inspector set the projection to orthogonal and the size to 19. Now let's try our game. Hit here the play button and we will have to define a main scene. A main scene is the one that is played as soon as we start playing. So for now let's select the current one. As you can see, with WASD I can move. I can also move diagonally, and if I press the spacebar, as you can see, currently nothing is happening because we haven't actually set up the jump. Create a scene with once again a character body 3D node as its root, name it mov, add a child node, node 3D, name it pivot, and drag and drop the file mov glb from the file system doc onto the pivot to add the monster 3D model to the scene. You can rename the newly created mov node into character. Add a collision shape 3D to our mov node. In the inspector, assign a box shape 3D to the shape property. We should change its size to fit the 3D model better. You can do so interactively by clicking and dragging on the orange dots. I want to delete the mov if it exits the screen to avoid performance issues. To do so, add a visible on-screen notifier 3D. Another box, pink this time, appears. When this box completely leaves the screen, the node will emit a signal. You should resize this box as well. Let's create the mov movement, so attach a script to it. We define two properties, min speed and max speed, to define a random speed range, which we will later use to define the velocity. Similarly to the player, we move the mov every frame by calling the function move and slide. This time we don't update the velocity every frame, we want the monster to move at a constant speed and leave the screen even if it were to hit an obstacle. We need to define another function to calculate the velocity. This function will turn the monster towards the player and randomize both its angle of motion and its velocity. The function will take a start position, the mob's spawn position, and the player position as its arguments. We position the mob at start position and turn it towards the player using the lookAt from position method, and randomize the angle by rotating a random amount around the y-axis. Below randf range outputs a random value between -pi divided by 4 radians and pi divided by 4 radians. We got a random position, now we need a random speed. Randy range will be useful as it gives random int values, and we will use min speed and max speed. Random speed is just an integer and we just use it to multiply our velocity. After random speed is applied, we rotate velocity vector 3 towards the player. Here's how the final function of initialize should look like. We still have to destroy the mobs when they leave the screen. To do so, we'll connect our visible on-screen notifier 3D node's screen exited signal to the mob. From it, call the queue_free method. This function destroys the instance it's called on. In this part, we are going to spawn monsters along a path randomly. Before drawing the path, we are going to change the game resolution. So, go to Project, Project Settings, navigate down to Display, then here Window, and here as you can see we can change the viewport width and height. So, let's put the following resolution, 720 by 540. Select here, click just here like anywhere in the viewport, and then press Ctrl 2. By this way you will have one window with a preview of the camera as you can see, and the other one like with the normal camera that we can move around. Okay, what we want to create actually is a path from where our mobs will spawn. Let's add a placeholder meshes. Add a new node 3D as a child of the main node and name it cylinders. We'll use it to group the cylinders. Select cylinders and add a child node mesh instance 3D. In the inspector, let's create here a cylinder mesh. In our window from the bottom, we're gonna click here where it says perspective and then here top view. We can see we have this like grid here, so let's actually disable that. So we go here to view and then here we disable view grid. Now what we need to do is actually this cylinder right here that we have created, we have to make it that we can't look at it in our preview. So let's select here the mesh instance 3D. We're gonna actually turn on here the snap, okay, and then using here the move mode, okay, I'm gonna actually move it to a point where I don't see it here, okay, in a top left corner. So maybe right here, then I will move it a little bit left, and okay, now it should be working. You can even zoom a little bit, move the camera view whatever you want, but okay, there, as you can see, should be working fine. As you can see, I don't see it, now I see it, now I don't, so here should be the correct position. So now let's actually duplicate it with Ctrl D, and this copy we're going to move it down again, making it that we can see it right here in a preview, so it's going to be right there. Then we're gonna select both meshes, duplicate them, and now move them to the right. Okay, something like this should be okay, I think. It is quite complicated, as you can see, to actually see the different spheres as they are white, and our floor is also white. So let's select all our cylinders, select here the mesh, and then here in material create a new standard material, then click here again. Inside this property right here we can change its color to literally anything you want. Maybe let's make them, I don't know, white or blue, maybe something like this. And well, now as you can see here, we can clearly see the different cylinders. Add a child node path 3D to main node. In the toolbar, 4 icons appear. Click the add point tool, the icon with a green plus sign. Click in the center of each cylinder to create a point. Then click the close curve icon in the toolbar to close the path. Then the final path should be looking something like this. To sample random positions on it, we need a path follow 3D node. Add a path follow 3D as a child of the path 3D and rename the two nodes to spawn path and spawn location respectively. With that, we are ready to code the spawn mechanism. Attach a new script to our main node. We first export a variable to the inspector so that we can assign the mob scene or any other monster to it. Now let's actually assign our mob scene. In order to spawn the enemies on a time interval, we're gonna add a timer on our main node. In the inspector, set its wait time to 0.5 seconds and turn on auto start so it automatically starts when we run the game. Name it mob timer. With the mob timer still selected, head to the node dock on the right and double click the timeout signal and connect it. As you can see, we have a new function created in our code. Instantiate the mob scene, sample a random position on the spawn path, get the player's position, call the mob's initialize method passing it the random position and the player's position. Add the mob as a child of the main node. Now, when we play the game, we can see that the different mobs are spawning. As you can see, well, of course, their behavior is still not the best, but well, as we can see, they are spawning. In this part, we'll add the ability to jump and squash the monsters. So the first thing, again, is go to the project settings. Now navigate down until we see layer names, and then we go to 3D physics. The first 3 layers should be player, enemies, and world. Now let's select our ground right here, go to the inspector. Under here collision, we can see the layers and the masks. And well, actually you can see here the layers that we've just created. So actually our ground is part of the world. So let's disable this first layer and move it to the third one. And we will also disable the mask because we don't actually want to detect collisions with the ground. So this mask would actually be useless. Now let's save the changes with Ctrl S, go to the player, and we're gonna do something very simple. We're gonna go to the player object, then here in our collisions, here, we're gonna leave the first layer as default because this is the player, and then in the mask we're gonna disable it with the player because we don't want this player to collide with other players. Actually, we only have one player, but well, just to avoid any issues. And actually the player will be able to collide, of course, with other enemies to detect the game over on when we are squashing them. And of course the collision with the world, so that our player can detect collisions with the ground and it doesn't like fall down when it jumps, okay? Again, save the changes, now go to the mob scene. Let's do again something very similar, collision, and here in the layer, in this case, this isn't the player, these are the enemies. and then in the mask I'm gonna disable them. These settings mean the monsters will move through one another. In order to create the jumping, first of all create an export bar with the jump impulse. Add the following code before the move and slide code block. The isOnFloor method is a tool from the character body 3D class. It returns true if the body collided with the floor in this frame. That's why we apply gravity to the player, so we collide with the floor instead of floating over it like the monsters. If the character is on the floor and the player presses jump, we instantly give them a lot of vertical speed. As you can see, when trying it out, we can press the spacebar, and as you can see, it works perfectly fine. Let's add the squash mechanic next. Go to the mob scene, then click in the node tab and finally groups. There we'll create a group named mob. We can now use the group from the code to differentiate collisions with monsters from collisions with the floor. Head back to the player script and let's create another variable called bounce impulse. After our move and slide function, let's write the following code. With move and slide, Godot makes the body move sometimes, multiple times in a row to smooth out the character's motion, so we have to loop over all collisions that may have happened. In every iteration of the loop, we check if we landed on a mob. If so, we kill it and bounce. With this code, if no collisions occurred on a given frame, the loop won't run. The functions getSlideCollisionCount and getSlideCollision both come from the character body 3D class and are related to move and slide. Then we use that information to actually verify if there is some collider. Then if that collider is inside our mob group, which means that we are colliding with the mob, we also store this collider. To check that we are landing on the monster, we use the vector.product. A value higher than 0.1 tells us that we are roughly above the monster, exactly what we are going for. After that, we call that it's actually an undefined function that we are gonna create just in a second in our mob. We apply the bounce right here and then we break the statement to avoid duplicate calls using the break statement. So now let's actually create this squash function. So let's go back to our mob script. At the top of the script, let's actually create the signal that will be emitted once we are squashed. I mean, we are telling that the mob is squashed. And at the bottom, you can add the squash function where we emit the signal and destroy the mob. So now let's try it out. Let's try to squash some enemies. Come here, boy. Okay, we squash one. We have 3 until here. And well, as you can see, when we squash them, we have like a little bounce right there. And you can actually tweak all these variables right here. We can kill enemies by jumping on them, but the player still can't die. Let's fix this. Head back to the player scene and add a new child node area 3D. Name it mob detector, add a collision shape 3D node as a child of it. Assign a cylinder shape to our collision shape 3D. Here is a trick you can use to make their collisions only happen when the player is on the ground or close to it. You can reduce the cylinder's height and move it up to the top of the character. This way, when the player jumps, the shape will be too high up for the enemies to collide with it. Next, select the mob detector node again and in the inspector turn off its monitorable property. This makes it so other physics nodes cannot detect the area. In our collision, we are gonna disable its layer of player and we are gonna change its mask to just enemies. Let's now connect the body enter function that all areas 2D gives us to our player. Code-wise, we are going to do two things. Emit a signal we'll later use to end the game and destroy the player. We can wrap this operation in a die function that helps us put a descriptive label on the code. If your player can't die, just make the radius even larger. With this, when you play and you collide with an enemy, as you can see, you die and then, well, this drops a an error because our player has been deleted it, okay? So be patient, we are gonna correct this. In order to end the game, open your main scene, select the player and connect its heat signal to the main node. Now here we will just get the mob timer and we will stop it as well. Now when we play it and we die, as you can see, monsters stop spawning and there is no error, no anything, everything works just fine. In this part, we'll add the score, music playback and the ability to restart the game. In the main scene, add the control node as a child and add a label as well. Name the control node user interface and the label score label. In the inspector, set the label's text to a placeholder like score 0. Let's change its color, so scroll down, theme overrides, color and turn on font color. Now our text is black and let's move it a little bit away from the corner, maybe right here. Let's create a new theme in our user interface, so click here theme, here where it says empty, and let's create here a new theme. Now when we click here, as you can see, we have a new window. Here in the default font, let's quick load the font that we have downloaded, and we can also give it a size of, for example, 22 pixels. Let's attach now a new script to our score label and define the score variable. The score should increase by 1 every time we squash a monster. We can use their squash signal to know when that happens. At the bottom of the onMob timer timeout function, add the following line. This line means that when the mob emits the squashed signal, the score label node will receive it and call the function onMob squashed. Head back to the score label script to define the onMob squashed callback function. There we increment the score and update the displayed text. The second line uses the value of the score variable to replace the placeholder %s. When using this feature, Godot automatically converts values to string text, which is convenient when outputting text in labels or when using the print function. Now, when we play it, as you can see, our score increases 1 when we squash an enemy. We'll now add the ability to play again after dying. When the player dies, we'll display a message on the screen and wait for input. Inside our user interface node, let's add here a color rect. Change the anchors to full ratio, and then do the same thing with the user interface. Also here change the order of the nodes. So now we can now see the score in our screen. Finally, rename this color rect to retry, and then let's change its color to black. Add a label as a child of the retry. Using the anchors, again center it, and write here something like press enter to retry. In our main script on the ready function, we're gonna hide this overlay we've just created. Then when the player gets hits, we show the overlay. Finally, when the retry node is visible, we need to listen to the player's input and restart the game if they press enter. If the player presses the predefined UI accepts action, which is actually the enter key, and retry is visible, we are gonna reload our current scene. Let's try it out. So when I die, I have my retry message, I press enter and the game is completely restarted. In order to add our music, we create an audio stream player, quick load the music we have downloaded and set autoplay to true so that it is played as soon as we start playing. And now when we play, we will have our music. So now you have a completely playable 3D game made in Godot. If you smash that like and subscribe button, I will continue uploading more similar courses. Question time: why will you learn or use Godot instead of other engines like Unity? Leave your answers in the comments down below. Finally, this course was made following the 3D course that you can find in the Godot docs, link in the description. See you in the next one and bye bye.